Okay, here's another example. Chlorate ions and iodine react in an acidic solution to produce chloride ions and iodate ions. So the first step is to figure out what our oxidation numbers are. So iodine is an element, so it has an oxidation number of 0. Chloride on the right is just a monoatomic ion, so its oxidation number is its charge, -1. So then you've got to figure out for chlorate, so chlorine plus 3 oxygens equals the charge on the ion, which is -1. Chlorate, it's not a peroxide, so the oxidation number on the oxygens is -2. So chlorine plus -6 equals -1. So chlorine has to be +5. Alright, so we're going to do the exact same thing on the iodate ion on the right hand side. So iodine plus 3 oxygens equals -1 charge on the ion. And iodate ion's not a peroxide, so this iodide plus a -6, 2 times 3. So iodine is also +5. Alright, I have erased all the work, so this is neater. And we have our oxidation numbers of the species that have changed oxidation numbers. So method A, balancing our redox reaction using oxidation numbers. So we've done step 1. We've assigned oxidation numbers. So now what we're going to do is figure out how many electrons are transferred using the change in oxidation number and the subscripts. So chlorine changed. Let's use blue. Chlorine changed. And it went from +5 to -1. So it gained a total of 6 electrons. The subscript on the left is 1. The subscript on the right is 1. So we have a transfer of 6 times 1 electrons. Now we're going to do the iodine. I usually do one on top, one on below. It's just neater. So iodine, it went from an oxidation number of 0 to an oxidation number of +5. So this lost electrons, and it lost 0 to +5, 5 electrons, but the subscripts aren't the same. We've got 2 here and 1 here. So I have to multiply the transfer of electrons by 2. And I'm going to put a 2 in front of the IO3 to make the atoms balanced in terms of iodine. So when you have to balance an atom other than oxygen and hydrogen, going by the subscripts, you have to multiply the electrons that were transferred by that coefficient as well. So this is why you figure out how many electrons were lost first. Then I had to balance the iodine with a coefficient of 2, and that's my multiplier, times 2. That's why in the others I showed you times 1. If the electrons are the same, you don't change, if the number of atoms are the same on both sides, then you don't change them. You multiply by 1, which is essentially leaving it alone. Here, we multiply by 2, to balance the iodine. So this is a total of 10 electrons, and this one is a total of 6 electrons. So we have to figure out what number these both go into. What's the lowest common multiplier? And it has to be a whole number. So what do they both go into? So 6, if you multiply it by 5, you get 30, and 10 goes into 30. So what we're going to do is we're going to multiply this by 5 to get 30 electrons. Because don't forget, the number of electrons has to be the same. And if that's the case, I have to put a 5 in front of both the chloride and the chlorate ions. So whatever's connected by my blue line, I have to put that multiplier on. So we're going to do the same thing now with the oxidation. So we need to multiply this by 3 to get 30. Number of electrons gained have to equal the number that were lost. So we will now have to multiply everything by 3. So there's a 3 here, but there's already a 2 here. We have to multiply that by 3. So this is going to become 6. 3 times 2 is 6. So we should have, by this point, balanced the number of chlorines and iodines on both sides. So let's check. We've got 5 chlorines on the left, 5 chlorines on the right. We've got 3 times 2, 6 iodines on the left, 6 times 1, 6 iodines on the right. So that's balanced. Now all we have to do, all the hard work's done. Now what we have to do is balance for oxygen with water and balance for hydrogen with H+. So on the left hand side we've got 5 times 3, so 15 oxygens. And on the right we've got 3 times 6, 18 oxygens. I should write this down so I don't lose track. So we've got 15 oxygens and 18 oxygens. So we need 3 waters on the left. That's our only source of hydrogen, so we must need 6 H pluses on the right. So our reaction should be 3 waters, 5 chlorates, 3 iodines, goes to 5 chlorides, 6 iodates, and 6 H+. I'm only rewriting it so it looks neater. If this was correct, you could just leave that. Alright, so balance for charge. We've got a total negative charge on the left of 5 negatives, because that's 0 and that's 0. On the right side, we've got 5 negatives, 6 negatives, and 6 plus. So these cancel charge, 5 negative. All right, 6 H's, 6 H's. 3, 15, 18 oxygens. 6 times 3, 18 oxygens. 5 chlorines, 5 chlorines. 6 iodines, 6 iodines. So this is our balanced reaction. So we have again balanced chlorate and iodine producing chloride and iodate in acidic solution because we've got our H+. Now we're going to balance using our half cell reactions. So this is the information that we got. No point redoing it. You only have to do one method when you balance. So we figured out what our oxidation numbers are. So we know that we're going to have an oxidized reaction, half reaction, and a reduction, half reaction. So chlorine, gain 6 electrons. So gain, Leo the line says GR, so gain is reduction. And that must mean 0 to +5, it became more positive, so this is oxidation. Loss of electrons is oxidation. So there we go. We have our 2 half reactions. So let's do oxidation first. We've got I2 going to IO3 negative. Okay, so balance this. So we're going to balance all atoms other than oxygen and hydrogen. So we need a 2 in front of iodate. Now we're going to add water to balance the oxygen. So on the right hand side, we've got 6 oxygens. So we need 6 waters. So now we're balanced for oxygen, which means we've got to add 12 hydrogen ions on the right to balance for the 12 H's on the left. Now we have to balance with charge. So total charge on the left is 0. We've got 2 negative and 12 positive for a net of 10 positive. So we need to add 10 electrons. So this half cell reaction is balanced. Now what we have to do is balance the reduction. So we've got chlorate going to chloride. So we've got 1 chlorine on the left, 1 on the right, so chlorine is balanced. We need to add water to balance for the oxygens, and we're going to add hydrogen ions to balance the hydrogens on the right hand side. Now one trick here is when we're adding these, the hydrogens and the electrons always go on the same side. So right hand side, we've got a -1 net charge. This is 0, this is -1, add them together, -1. Here we've got a -1 and we've got 6 pluses. So we've got a total positive of 5 plus on the left. So we have to add 6 electrons to the left to keep that a total -1 charge on the left hand side. So we need as many electrons as we have hydrogen ions. Okay, so now we get to balance. So these two independently are balanced, but now we have to balance for total electrons transferred. So the number taken have to be the same as was given. So redox reactions, the total number of electrons are going to be the same. So again, we already figured from the last one that we needed a 30. Both 10 and 6 go into 30. So we're going to multiply everything in the first reaction by 3, and we're going to multiply everything in the second reaction by 5. So this becomes 30, this becomes 36, this becomes 6, this becomes 3, and this becomes 18. Balance everything in this, multiply everything in the second equation by 5. So this becomes 30, this becomes 30, this becomes 5, this becomes 5, this becomes 15. And then what we do is we add them up and cancel anything that's on both sides. So over here we've got 18 waters. Well, down here we've got 15 waters. So this 15 gets completely canceled and we're left with 3 waters. So 3 H2Os. Then we've got 3 iodines, and there's none of those on the right, so that's I3, I2. Still on the left, second row, we've got 30 electrons. So we're going to cancel these with this 30 electrons, so they're gone. Then we've got 30 H plus down here. We've got 36 H pluses up there, so these 30 get canceled, which leaves 6 of the, or 36. So on the right hand side, we have 6 H pluses. We've got 5 chlorates on the left. On the right, let's see what we've got left. We've got 6 IO3s and 5 chlorides. So this should now balance. So let's double check. 6 H's, 6 H's. 3 and 15 is 18 oxygens. 3 times 6 is 18 oxygens. 6 I's, 6 I's, 5 chlorines, 5 chlorines. So we're balanced for atoms. Now, balance for charge. This is 0, 0, -1 times 5, so -5 total. 6 plus, 6 minus, so those cancel. 5 negative, remaining. So this is now balanced, both for charge and for ion, for charge and atom. So this is a balanced redox reaction in acidic solution. And there you have it.